Hi, this is Omar Cabrera with methanetrackers.org, and today I want to walk you through the Unified Methane Layers view on the methanetracker.org website. Alright, I want to use the opportunity to show you best practices and how to avoid a couple of the bugs that Google Earth has when trying to display a lot of data. The first time you go, the time slider is going to go by itself. We want to stop this, just grab it and move it somewhere near the end. And then don't go all, if you see the red X, then just move a little bit to the left. There you go. And now we're going to grab this slider, the left part of it, and just go to the beginning. I'm using a Mac. It has a really good 3D hardware acceleration, and I have a speed of about 5 megabytes per second. So a month takes about 15 seconds to 20 seconds to load. And what we're doing here is we're loading all the methane into memory. Let's see what it looks like now. See, that's what I'm talking about. Now that it's in memory, everything moves a lot faster. What you may want to do is, the first time just start it with methane, but if you know that you're going to be working with a data layer, just pick the data layer that you're going to be using. Let's say, for example, we're going to go with Aqua, True Color. This one is pretty heavy because it loads a lot of imagery, and it's going to take a while to load. So this is what I want to do. I'm going to change the from date from June to January 1st. This is the first day that we had data of, and it's going to be loading the there you go, Aqua. Same thing. Just gonna go here. In my computer, I need to go like something like this. It really changes from computer to computer, and from bandwidth to bandwidth. It's gonna depend on what you have. It might be less, it might be more. But you'll see it wide, and then as soon as it loads into memory, you can move it to the next one. What I'm gonna do is pause the video recording, and I'm gonna resume as soon as everything is loaded in memory. Okay, we're ready to look at the methane. Now everything is loaded in memory, and it just moves pretty fast. This is exactly what you want to do for every single data layer that you're working with. Let me give you a couple of just really basic concepts. IASI is an instrument aboard the Meta series of satellites of the European Space Station. And what we're doing is grabbing the methane readings that they have. They have 2 per day, one in the morning from 0 to 12Z, and one in the afternoon from 12 to 24Z. And what we're doing is getting only the methane that is off the charts, which appears yellow on each one of their individual layers, 100 layers in the morning and in the afternoon, and we're flooding them into 2 layers. So one in the morning, one in the afternoon, with all the methane for every millibar. Okay. Let's look at. Right now we're in 1 day. So what we're going to do is we're going to grab this and say make it, I don't know, just a few days. We're from 5th. Let's do 10 days. So right now we're looking at the methane of 10 days. Now, as soon as you do this, you start noticing patterns. Look at this. Let's look at this right here. And this is one of the main differences between, CO2 scientists. don't understand why methane scientists freak out, and this is, I think, part of the reason why. Uh, Look at this. In a matter of days, just days, we're having this huge area. Look at this, going almost exploding with methane. Now, because of the see that it's coming, you can almost pinpoint the places where it's coming from. The only way this is possible is by melting of methane clathrates. It's just the only explanation. It's way too much methane to be coming from. See, I mean, it keeps going. It's way too much methane to be coming from the actual ice being melted, which is something that has surprised everybody. And the idea is that you can use this Unified Methane Layers feature to identify an area, a geographical area in a date range. Like right now, I think it would be, it should be a little bit before, like right here. I think that it would be a good idea to analyze on the individual methane layers from February 10th to February 24th because something happened there. There's definitely something happened. It would be interesting to look at the sea surface anomalies in the area, ice concentration, and direction of winds, and see how everything plays together. Also, look at this methane coming from Greenland. There's a lot of mountain ranges right here, so it's pretty crazy. Let me show you a couple of examples more. Deserts. And I really don't know if this has been a problem always, or it just became a problem and we noticed this just now. Well, methane is not supposed to be coming from deserts. It's just, I mean, everybody's focusing on the Arctic. Some other scientists are concerned about the Antarctica. But almost all the research is being focused on right here on the East Antarctica, like right here on the SS. Now, look at this. I mean, the desert is just boiling. Look at how it moves from west to east. See? It's almost like it's following. Well, Apocalypse for Real had a really good hypothesis, and his hypothesis is that it's following, and this is caused by rain, precipitation. Something that actually that was the first thing that I did, and then he told me he had done it too, is go and check on one of the true color layers to see precipitation, like just by looking at the clouds. It's not only in the Sahara, which is, I mean, it's huge, but it's in pretty much every desert. Let's look at the Gobi Desert right here, and China and Mongolia. Look at this. It's just the same. Even, it doesn't seem to be only that. Even in South America, which is normally a place where you don't find methane at all, the methane that is coming from, can you see it? It's in the only desert in South America. Look. Amazing. So basically, Unified Methane Layers allows you to take a look at 10 days and try to find patterns, and in the pattern identify a geographical area that is of your interest in a date range.